the numerical problem related to light chapter, okay? And only the numerical problems we are going to discuss, okay? So before starting this chapter, let me give you the proper sign conventions, okay? That we usually take during the when we are solving the problems, okay? So let's study that one. So actually, you are very much familiar that whenever we are just taking this, this is a Christian plane, okay? And this is a positive x-axis, this is negative of x-axis, this is positive of y-axis, and this one is negative of y-axis, okay? So if I am going to measure any distance that is in the negative x-axis, that is going to have the negative value, okay? So anything that we kept here in the lens, either it is a lens or a mirror, we always used to keep it on this y-axis, along this y-axis. If it is lens, it is kept here like this. If it is mirror, it is kept like this, or it is kept like this. Okay. So this is arbitrary chosen that we are just going to keep the lens, mirror, or anything that is that we are using any instrument. Okay. That we used to usually kept along the y-axis. Okay. So if anything that is if anything is being kept here, okay, that it is a mirror, anything. So if I'm measuring a distance from here to here, that is called object distance. Object distance, and it is always taken as negative. It will always taken as negative. Why? Because whenever an object distance is given to us, we have to take that value the negative. Why? Because this distance is measured in negative x-axis. Similarly, we always keep, this is an arbitrary chosen. This we have chosen that we always keep the object on the left-hand side, okay, and over the negative of x-axis. So if you keep this distance like object here, so if you need to measure this distance, the height of this distance, height of this object, so this will be measured along this length. If it is this much tall, then you have to take this length. If it is this much tall, then you have to take this length. So we are just going to measure the y-axis for measuring the object distance. So we can say that the object height is always measured in negative. Okay, object height, the height of object is always taken as positive. Okay. Now, if it is mirror, then the image may be formed. If the real image is formed, if it is mirror is taken here like this, okay, then the image, if it is formed real inverted image is formed, then this distance, the height of this image will be taken as negative. Okay, so we can say if image is inverted, whether it is here or here somewhere, we don't care. If it is inverted image, then it will be below the x-axis, and for measuring the length of this one,
so that will be V, right? Image distance.
Yeah, image distance means V. No, image distance means height of image I'm talking about. In height of image, if it is inverted image, height of image, if it is inverted, then will be taken as negative. If it is not inverted, it will be erect. Erect means upright. So if the image is formed here, or here, anywhere, so it will be taken as positive. The image distance will be taken as positive. So this will be taken as positive. Okay. So if I'm talking about the erect image, then it will be upright. Upright means positive. Similarly, for upright, positive image distance. Image height. And if I'm talking about the V, if image is formed here, if I'm talking about the image distance, and if the image distance is either here, then this is measure. If the image is formed on the positive x-axis, on this side, on this portion, so whether it is forming here or whether it is forming here, okay. So if it is on the positive sides of the x-axis, then it will be taken as positive, okay. And if it is forming either here or here, where it is image is formed, If it is formed on the negative x-axis, then the image distance will be taken as negative. Okay. Similarly, that you need to keep in mind, either it is a lens or a mirror. If I'm talking about convex, just tilt this x. When you tilt the x, you will get plus sign. So means convex lens or mirror have positive focal length. Okay. And concave lens and mirror have negative focal length. Okay. Have negative focal length. So if it is concave, whether it is a lens or a mirror, they are both going to have the negative focal length. You need to keep in mind that while solving the problems, you need to. Okay. Now, if I'm talking about the mirrors and the lens, okay, if I'm talking about the mirror and the lens, we need to keep in mind, we need to keep this in mind, that what we need to keep in mind, that if I'm talking about the mirror, I'm just writing here mirror, we have some formula for the mirror, and for the lens, and some we are having common formula, that is for both. So for mirror formula, we have 1 upon f is equals to 1 upon v plus 1 upon u. And here we have 1 upon f is equals to 1 upon v minus 1 upon u. This is the lens formula. Said magnification is here the magnification is magnification formula is minus v by u, or a height of image to the height of object. Okay, if I'm writing minus v by u only here, and here magnification is plus v by u, and that is common. The formula for common magnification is height of image to the height of object. There is no positive and negative side. This work for both lens and mirror. You have to put the sign. If you are talking, means you have to put the value according to the signs. Height of the image. If the image is formed here, then this will be measured in the negative, or here this will be measured as negative. And if it is forming upright image, then you have to put the height of the image as positive. Okay, so we have to put that value according. Next, what we need to do here is, this is 1 upon f, and this is the formula for the mirror. And we have some common formula, that is f is equals to mu upon m minus 1. And here f is equals to, if we have mirror, if we have only magnification and u is given to us, only magnification and u is given to us, and focal length is being asked, or if focal length or magnification is given to us, object distance is being asked. So if any two of them is given, no v is given to you, then in that case, we have to use this formula. For the mirror, we have this formula, and the same we have for the lens, we have m u upon 1 minus m. Okay, and the common formula, that is for both, f is equals to v upon 1 minus m. If we don't have the, if we have given only focal length and mirror, and v is being asked, or if we have given magnification and v, focus is being asked, so we have to use this formula for common for both lens and mirror. So please note it down.
So can you explain f is equals to mu by 1 minus 1 again?
Yes, f is equals to mu upon m minus 1. We will do the numerical based on this one. We are just going to discuss this one. This is the simple formula that if you have been given the magnification, an object from 3 times magnified image means we can simply say that a lens from a 3 times magnified image of an object plays a resistance of 30. Calculate its focal length. So object distance is given, magnification is given, then you can calculate the formula by using formula. If it is lens, then you have to use this one. If it is mirror, then you have to use this one. But instead of if it is, if in the question it is being given that an object forms an image of an object, or it can be a mirror or lens, anything, because this is common for both. So let assume that it is a mirror, and a mirror form. Okay, a mirror forms the image of an object at a distance of 30 meters. So if image for distance is 30 meters given to you, and the image is diminished and is of 0.5 magnification. 0.5 magnification. Find the focal length. So this type of question can be asked in the examination. So we are just going to discuss this one. Okay. Now you understood? So please note it down.
Yes, sir.
Everybody, please note it down. This is very important. I recently explained you that what I have explained you earlier, that you have to use the proper sign conventions for solving the numerical problems. Okay, for solving the numerical problems, and you need to keep in mind every time the things that is being given to you, you have to put that value according to the sign conventions. The thing that is not being given to you, you have to put that. You don't need to put that one. Okay, I will discuss that when we will solve the numerical. Then you get to know that what I'm saying. Who is this one? He is again and again joining and leaving. Okay, now you understood. Have
Yes,
you
sir.
noted this formula, everyone? Now you need to keep in mind, everybody. You need to keep in mind here that what do you need to keep in mind? Is my voice is breaking or is it clear to you? Is my voice is clearly audible? Clear now?
Yes.
Okay. So if I'm saying that let's suppose, okay, wait up. Okay, let's suppose we will start solving the problem right now. Okay, so you need to know, before running this one, you need to know the basic knowledge of image formation by mirrors and lenses. If the object is placed beyond F, then the image will be formed between R and F. Sorry, if the object is placed beyond R, then the image will be formed between R and F. If the object is placed between R and F, the image will be formed beyond R. If the object is placed exactly R, then image will be formed exactly R. Okay, so this type of, if the object is placed between pole and focus, the image will be formed behind the mirror. If it is the lens, then it will form on the same side. So this is the knowledge of means the basic knowledge of image formation. So let's start solving the problems, and let's have some important points regarding to this one. Okay, so these are the very important questions, and everyone need to understand this one thoroughly. Okay, so dear students, this is a very important book, and I want every student to practice this NCERT exemplar for your board examinations. Okay, if you have time, because you don't have extra time, you have to, every time you need to study this time. Okay, every time you need to keep on studying. So dear students, it's my request to everybody that you must keep on practicing these numerical problems, and this will help you a lot. This will build your base. Okay, so let's take the examples. Sorry, let's take any questions from this one. Okay, let's take this question. Let's take this question. Question number 36. Okay, let's solve this question. So if this question is given to you, okay, has the size of an object, by a mirror. So size of the image of an object by a mirror having a focal length of 20. Okay, here it is not being given to you that it is a converging mirror or a diverging mirror, or is it a concave mirror or a convex mirror. Okay, but focal length is being given to you. Okay, just keep in mind here the focal length is being given to you, and this is a 20 centimeter being given to you, and reduced to the size of, means the image size is reduced to 1/3 of its original size. So we can say here that the magnification is 1/3. If it is 3 times, yes,
Is it diminished?
yes, it is diminished. 1/3 of its size means we can say that the magnification is given to you. If it is saying 3 times the double of its size 3 times, so it means 3 times magnification. M is 3. If it is giving 1/3 of its size, the image is becoming 1/3. So what does it mean? It means the magnification is 1/3. At what distance? At what distance means object is being asked. At what distance the object has been placed from the mirror, and what is the nature of the image and the mirror, and what is the nature of the image and the mirror. So just what is being said here, the size of an object by a mirror, the size of image of an object by a mirror having a focal length of 20 centimeters is observed to reduce 1/2 size. Okay, and now you know that if it is, it can be do you think that it can be a concave mirror or a convex mirror? How many of you can give me this answer?
Is it concave?
Why not convex? Why not convex? It is not saying anything.
It can be
It is not.
convex as well, because convex produces diminished images also.
Yes, it can be. So the mirror can be here. You need to think here that the mirror can be both, because it is not mentioned here. It is not mentioned here. Then just listen to me, and everyone please stop writing when I'm talking to you. Just listen, concentrate on the screen first. What I'm saying here, it can be a concave mirror as well as convex mirror, because diminished image is formed by both concave and convex mirror. Diminished image is formed by both concave and convex mirror. So if I'm saying this is focus and this is radius of curvature, okay, and if the object is placed beyond R, then the image is formed here and this is diminished. The case first is this one. But this type of image formed is real image. And if you are having the convex mirror, so convex mirror always form a diminished image. So wherever the object is placed, the image will be formed between focus and pole. The image will be formed here. So we can say if the behind the mirror image will be formed, and it is also diminished. Okay. So in both the cases, so if we are considering here that the image formed is real image, if we are just considering that the image formed is just if I'm considering that image formed is real image, so the magnification for real image is taken as -1/3. And if the real image is formed, then it can be only formed by which type of mirror? Everybody please turn on your camera. Jovita, why did you?
By concave mirror.
So if I'm saying that if it is then the focal length, if I'm just considering that a real image is formed, then it will be always formed by concave mirror. Real image diminished can only be formed by concave mirror. So it can also be formed by convex mirror diminished image, but it will not be we can say real image. It will be a virtual image. So if I'm just considering case one, real image is formed. Real image is formed. So in case, dear student, real image is formed, then we take the magnification as 1/3 and the focal length will be taken as -20. -20. Why we are just considering this -20? Because concave mirror, I told you, whether if it is concave mirror or concave lens, both of them are going to have negative focal length. Okay. So what is being asked? U is being asked. U is being asked. Where should the object be placed?
Is it like,
Yes.
are you taking assumption of concave and convex both?
Yes, because the question is not being given to you. In the question, it is not being given to you. We are just taking the assumptions. Like considering that it is a concave mirror, so the image will be formed at -1/3. Focal length will be taken as -1/20. Okay, and U, what's U? You need to calculate the value of U. So you have written the formula that U F is equals to, in case if F and the formula that is showing the relation of F, M and U, that is F is equals to mu upon M minus 1. F is equals to that. You have written this formula for the mirrors. Okay, for the mirror, I have written that is for the mirrors. So put this formula according, and dear students, that you need to keep in mind here that we must assume the answers before solving it, because we must assume the value. We can easily predict the value. That value will be in the what should be the range of the answer, okay, in this questions. Why? Because it will help us to get the more appropriate answer, and it will help us whether if we are doing something, we are not doing any mistake. Okay, so you know that if 20 is the focal length, then the radius of curvature will be 40. Then the object must be placed beyond R in order to get the diminished image. So our answer should be greater than 40. Okay, in case of concave mirror. Okay, got it. And moreover, the things that are only given to you, we are just putting them with signs. We know that we always take the U as negative, but U is not given to us. So we are not just putting here -U. No. Only the things that are given to us in the question, we are just putting that according to the sign conventions. We are not putting anything that is not given to us and that we are need to calculate. That will automatically come with the sign. Here, whatever the value of U is going to come, that will be more than 40. It will be coming with a negative sign, because u is always taken as negative. So it will become with negative sign. So let's start solving this question. We have put this value minus of 20 here. And you know the magnification is minus 1 by 3. You have to put here minus 1 by 3. And you need to calculate the value of u. And then again, minus 1 by 3. Again, we have to put the value of m with sign minus 1. Okay, now what you will get? Now solve it again. When you multiply this one, you will get minus u by 3 here. Minus u by 3 here upon what you will get here. You will write here 1 into 3 into 3. So that in order to take the LCM, so you will get 3. You will get 3 and you will get minus of 1 and here you will get minus of 3. Okay. And this is 20 in front of you. This is minus of 20. Okay. Now this 3 and this 3 will get cancelled out. What you will get here? You will get minus of 20 and you will get minus of u upon this minus 1 and minus 3 will get plus, will get minus 4. Okay, this again, this is u. Don't think this is 4. And this is 4. Okay, this is 4. So this minus will get cancelled out. And when you multiply this one, you will get u is equals to minus 80. So here you know that u is equals to minus 80. Now, according to your question, your u should be greater than 40. Yes, it is greater than 40. It should be with a negative sign. Yes, it is with negative sign. So your answer is correct. Okay. Got it? Got it?
Yes.
Now moving to the next part of this question. Yes.
We'll be doing the other one also, the convex mirror also.
Yeah, we are solving the case second also. And in the case second, when we are having a diminished image of 1/3 size in convex mirror, so we don't have any special positions in the convex mirror that you need to place it beyond R, beyond F or no. No, we don't have. If you are putting the object anywhere between infinity and pole, you can have the diminished image and it should be of 1/3 size. So just keeping this one in with the sign. Now this, if you are just taking for considering a case 2, considering virtual images form, virtual image is formed using which mirror? Convex mirror. Okay, convex mirror. So now we have to put the sign convention according to, you know that focal length of convex mirror is positive 20, because convex mirror, whether it is convex mirror or convex lens, both are going to have the positive focal length. Okay, you understood? You understood, everybody?
Yes, sir.
Now,
Yes, sir.
again, the virtual image is formed. So virtual image magnification is also taken as positive 1/3. Okay. So for the magnification sign, if it is a real image, whether it is formed by lens or mirror, if the magnification will be taken as negative, whatever the value is given to you. But if it is virtual image, whether it is formed by mirror or either by lens, we need to take this as positive. Okay. Virtual image magnification is taken as positive. So we have to put here positive. And the focal length will be just taken as, okay. Now what we need to do here is, we need to again calculate the value of u. Now again put the same formula because it is mirror, and mirror have the same formula, that is f is equals to mu upon m minus 1. Now this time you have to put the positive value and u upon this again, this is 1/3 minus 1. And this time focal length is also taken as positive 20. Then you have to put this 20. Okay. And this will be taken as u by 3 upon this. Again, you take the LCM 3 and here you also get 3. Okay. This you also get 3. So you get 1 minus 3 here. Okay. Now this 3 and 3 will get cancelled. This is 20 is equals to u upon, this is 20, sorry, minus of 2. Okay. This is minus of 2. This minus of 2, you will get u is equals to minus of 40. Don't think that it is coming on the radius of curvature. No, it is not coming on the radius, because here in the convex mirror, the radius of curvature is here. Okay, focal length is here, not here. Don't think it is. If your answer is correct, that u should be negative and it can be anywhere. So here is, it should be 40. Okay. Here both in case of any mirror or lens, u should always be negative. If it is not negative, it means you have committed some mistake, some way mistake. Okay. So please, have you copied this question in your notebook? The question that I was discussing. Have you copied this question? Yes, students, please copy this question. Fast.
Sir.
Justin is saying it is convex mirror. Why it is convex mirror? No, we have to assume both the situations because it is not shown, not written anywhere that it is forming a virtual image of the real image. So please note it down here, students. Note this question. Past.
Done, sir.
Done? Okay, so please copy the answer for the both cases. Start doing this. Please copy this one. Have you noted this one? Then I can proceed to the next part.
Sir,
Yes,
can you show me the question one more?
one more time. Okay. Yes, students, it's my hearty request from everybody. Okay, everybody that everyone should make their notes, proper notes, uh, a separate copy for the physics, chemistry, and bio. If you are intermixing each and the notes of, and if you are not writing or maintaining your notes properly, then it will definitely affect your marks up to 20% in your final examination, board examinations. If you are maintaining notes of each and every subject properly, then the copy that I am teaching you, that is more than enough to score above 95% in science. More than 95%, you can easily, without any much efforts, you can easily bring 95% marks. So everyone is requested to keep practicing that we teach you, okay, every day. And moreover, please maintain your notes, the proper copy of every subject. Don't intermix your notes, okay? Don't make a single copy for every subject. Start doing maths, physics, chemistry, bio in a single copy. Don't do this. Otherwise, it will affect your marks up to 20%. So is it okay? Should I move to Jovita?
Yes, sir. Done, sir.
So please, have you noted this one?
Yes, sir.
Everybody in the class, is there anyone who wants to write this, copy this one? Done, everybody?
Yes, sir.
So
Done.
which
Yes, sir. Yes, sir.
Okay. Everyone? Okay. So do this one also. Have you noted this one also?
No, sir.
Noted fast.
so this
Done?
is convex mirror, right?
Yeah, this is convex mirror.
So then the formula should be F is equals to mu by 1 minus m, right?
No, this is m-1 is same for both mirrors. 1 minus m is for lens.
Yes, sir.
Okay, whether it is a convex lens or a convex mirror. For mirror, it is this, and for lens, it is 1 minus. Formula is same in both cases here. Okay. So should I move forward for the next question?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So let's take the next question. Okay. Let us start doing the next question here. Okay, do this question. That is, convex lens of focal length 20 produce a magnified virtual as well as real image. Is the statement is correct? If yes, where shall the object be placed in each case for obtaining these images? Okay, so now this is the same question is being given to you and the object distance is being asked. You know very well the same property of convex mirror is shown by the concave mirror. Convex lens and concave mirror both show the same type of image formations, almost same type of image formation. So this question is exactly same with the exactly same numerical value that you have done previous. That's the same question, but this time instead of mirror, it is convex lens. And you know here you have to write the means assuming here it is showing the magnified and virtual image as well as incorrect is it spent where should be the object be placed in each case for obtaining these images. So it is not asking you where you need to put the image. Okay, so let me explain you here. Okay, let me explain you what is saying magnified virtual images. Magnified images found, one is virtual and that is real. So you know. Okay, so you need to tell here the magnification is not given to you, dear students. Okay, so this is a convex mirror. So it is not asking you the exact value where should the object be placed. It should be a range. Okay, here should be the range only. Okay, so this is a convex. So if you put the object, if you want to obtain the magnified image, so you need to magnify it real. So it should be placed between R and F. Then the image will be found. This is F1 and this is sorry F2 and R2. And this is F1 and this is F1 and sorry R1, F2 and R2. So you know very well that if the object is placed in, this is a convex lens. If the object is placed beyond R and F, between R and F, so image is formed enlarged and this is magnified image and this will be formed beyond R. Okay. So dear students, you need to keep in mind here. Okay. And if you put the object, if you want to find the virtual image, so for the virtual image, you need to put the object between here, between pole, optical center and focus, and the image will be formed. It's not having any position. It will be on the same side, but it will be enlarged. This is virtual image. Okay. So this is the same question that you need to practice. Let's practice the next numerical, dear students. Okay. So let's practice the next numerical. So if the question is being asked, that the same question is being asked, the object, the focal length is 20. Focal length is 20 is being given to you. So where should be the object be placed for obtaining the magnified? So object here for the first case, if the image is real and magnified. Okay. So if the image is real and magnified, then dear students, the object must be placed greater than 20 at a distance greater than 20 but less than 40, means between R and F. The range should be means U should be greater than 20 but less than 40. Okay, for real image. And if it is asked for the virtual image, okay. So if the virtual image is being the virtual magnified image is formed, then the object should be placed after the F, okay, or between O and F. So if it is this length is 20, should be less than 20. So we should write here U should be less than 20. Okay, if it is less than 20, then we will say that the virtual magnified image will be formed. Okay, because it always form, if it is forming a virtual image, then it always form an enlarged image. Okay, so dear students, should I move to the next question? This is just an explaining question. Okay, should I move?
Yes, sir.
Yes, sir. Yes, sir.
So here is the next question from your side. Okay. Okay. Sudha finds out sharp image of a window plane of her science laboratory is found at a distance of 15 centimeters from the lens. She tries to focus the building visible to her outside the window instead of window in window without disturbing the lens. First of all, give an appropriate answer that where should she placed? Should she placed near the focus or away from the focus? In order, because anything you know that this is a convex lens. Okay, Shuda wants to obtain a window of a sharp image of a window of a science laboratory formed at a distance of 15 centimeters from the lens. So if it is a lens and she wants to obtain the image on the screen, so the screen means real image. If anything is obtained on a screen, so image obtained on a screen, image obtained on a screen. So it means real image, dear students. It means real image. No virtual image can be obtained on a screen. Okay, so it is real image. Okay, and now you know real image can only be found by convex lens. It is convex lens. Okay, and this if it is focus, if it is radius of curvature. Okay, so where should, and here it is being given that found at a distance of 15 centimeter. Okay, now read the question and let me please answer me the question. Here the screen is, this is also focus f2, and this is also radius of curvature. And where should the screen be placed? Away from the focus or towards the focus? Tell me. And what is the approximate focal length of this lens? Is there anyone in the class who can answer me this question? Is there anyone? Okay, read the question and just explain me what is being asked in the question. Read the question, please, everyone.
So sharp image means like point size.
Yeah, sharp image means. Yeah, sharp image
Point
means.
size.
Yeah, point size we can say. No, it's not point size. It's clear image. Sharp image means clear image. Okay, let me help you, dear student, to deal with this question because we are just discussing. So let me help you. Okay. So dear student, let's find out. Okay. So here I'm saying that Sudha finds out the sharp image of a window plane. Okay, from her science laboratory is found at a distance of 15 centimeters. So what is doing? Sudha wants to find a sharp image of a window plane. This is a window plane of her science laboratory, and it is found at a distance of 15 centimeters. That is found at a distance of 15 centimeters from the lens. Now she tries to focus the building that is visible outside the window. So let me help you. What is being asked in the question? Let me help you. What is being asked in the question? So this is a lens, okay, and this is O, optical center, and this is focus, and this is radius of curvature. This is F1, R1, F2, and R2. Okay, dear student. So initially, she was focusing a sharp image of a window that is at a 15 centimeter, 15 meter, sorry, 15 centimeter or 14 meter, 15 centimeter from the lens. Okay. And what is that image? Sudha wants to find out the sharp image of a window of a science laboratory is formed at a distance of 15 centimeter from the lens. So the image is formed at a distance of 15 centimeter from the lens. Okay. Yes, the image is formed. The image is formed at a okay. So if it is forming at a distance of 15 centimeter, that it is forming here, or it can form anywhere. We don't. Okay. Now the object is not at infinity. That window is here. Window is here. That this is a window. Okay. and the image or the screen of this window is found. Okay, here. And this is found at a 15 centimeter from the lens. Now she wants to focus the image of a tall building that is coming, that she can see from this window. Okay, the tall building is there, and she wants to focus the image of that. So should she place the screen towards the focus or away from the focus? Tell me.
Towards the focus.
That's the
Yes.
focus.
Yes, because as you are moving away from the lens, the image will come closer to the focus.
Lens.
Because if you are moving away from the focus, okay, if you are moving away from the lens, then you are going towards the infinity. Okay, as much as you are moving. So if I'm saying that, I'm just considering each and every case here. Let me explain you more betterly this one. But how can I say that she will bring the lens or the screen near the focus? How I can saying this one. So first of all, if she is bringing if she's obtaining a sharp image on a screen, so it must be real image, and it should be, the object must be placed either here or here somewhere. Okay. So she's focusing the image of the object here, and the image is formed beyond R. This is enlarged image, beyond R is formed. The screen is placed here. If she wants to place this object to here, if she is moving backward, so you know that this time the image will be formed. If it is on R, then the image will be formed at R. If she is placing the object here, then the image will be formed here between R and F. Means if she goes beyond R, then the image will form between R and F. It shows to infinity. As far she is moving, the object will be coming near to the focus. Okay, so we can say that if the object is moving away from the lens, the image will come closer to the lens, and the least closeness can be at focus. If it is the real image is obtained, the least distance where the image can be formed from the lens, it is at focus. Because infinite, if the object is taken to the infinite distance, then the image will be formed at focus. So the minimum distance the image can be formed is the focus. The real image can be formed is the focus. Okay. So let me learn this one again. Sudha find out the sharp image of the window plane on her science laboratory and found the distance at 15 centimeter from the lens. Okay, now the V is given to you, that is 15 centimeter. Okay, and because it is a lens, so it will be formed here in this region, so it will be taken as positive distance from the lens. Now she tries to focus the visible building towards instead of the plane without disturbing the lens. Yeah, okay. In which direction should she move the screen to obtain the sharp image? So she should move the image. She should move that one nearer to the focus. Okay. And what is the approximate focal length of the lens? So what can be the approximate focal length? So it should be less than 15 centimeter. Okay, because since she is focusing the image, so it should be less than 15 centimeter. We cannot have because at least we need two values to find out the anything. We need at least two values. We have only 15 centimeters, so we can simply say here that we can only give the rate. We cannot give the exact value here in this question. So she should place the screen because the object is moving far away from the lens. So she should place the screen nearer to the focus. And you know that if initially the image was the screen was placed here, and if it is this distance is 15 centimeter, so this distance, the focal length should be less than 15 centimeter. Okay, so everybody in the class understood this one? Should I move to the next question?
Yes, sir.
Yes, sir.
Okay, let's move. Let's discuss the next question. Yes, student, a very important question is being asked so many times in the examination. So let's discuss this one. This is also an important question. Okay. So let's discuss this one. So here, this type of question is also being asked. A student focus an image of a candle with a white on a white screen using a convex lens. He noted down the position of the candle at the screen. Okay. So here you need to keep in mind that the position of the candle is 12 and the position of the lens is 50. And you know that whenever we are just measuring any distance, we just measure everything from the lens, object distance, mirror distance, everything we are just measuring from this point. Okay, so if it is lens, then object distance we should be measured from here. Okay, now what is being said? The position of the candle is 12. So here it must be 0, and the position of candle is at 12 from this 0. From this 0, this is 12. Okay, and the position of convex lens is from here to here is 50. And the position of the screen means the image. If it is saying position of a screen means image distance. So the image distance is 88. Okay, 88. 88. So let's image is formed here. Then it is 88 centimeters. Can anybody in the class can give me the exact value of u? That what should be the value of u? And what should be the value of v here? According to this data, because we always calculate the value of u and v from the lens.
Is it 50 minus 12 like for
Yes,
the
it
U?
is, because actually we don't need to calculate from this here. Always calculate it from. Okay. Is I'm audible to you? Hello.
Yes, sir.
Okay. So we always need to measure the distance from here. Okay. So this is from here to here. We are just measuring. So this, if it is, this is 50 from here to here and 12 from here to here, this will be 38. 38 plus 12 will give 50. And now you know that from here to here is it. We need to calculate the V, this distance. So what should be this distance? So it is 50. This is also 38.
38, yeah.
Because here to here is 50. And from here to here is 88. From here to here is 88. So this distance will be 38, because 38 plus 50, this distance will give you 88. This is also 30. So here you see that u and v also are equal to each other. So when it is possible, when u is equals to v, if the u is equals to v, then the object is placed at r. We have one magnification. Okay. One magnification means, dear students, what do you mean by one magnification?
Same size.
Same size. Okay, so if here you can calculate that for the lens, m is equals to plus v by u. So here v should be taken as positive because this distance is in positive. So you will take 38, and u is always taken as negative. That is minus of 38. This is -1. So minus here sign indicate the real image, and 1 indicate of same size. And same size image of can be formed by convex lens when the object is placed exactly at r. So what are the questions being asked? What is the focal length of the lens? Tell me, what is the focal length? Tell me, what is the focal length of the lens now? Abir, Ashwin, Rubita?
19.
19, yes, because r is 38. So
38 by 2 will be
38 to by will be focal length. You know that convex mirror lens can give you the -1 magnification image. -1 means real, and 1 means same size when the object is placed exactly at r. So if this is 38 is r, so f will be half of this one, and that will be 19 only. Are you getting my point? Everybody in the class? Everybody in the class? Okay. Where will be the image be formed if he shift the candle towards the, where should be? Okay, if I ask you the question that ask you the question, where will be the image formed if we shift the candle towards the lens at a position of 31? So where should the image form? Tell me. Where will be the image form? So dear students, now you can calculate. You need to calculate this one. Now she is shifting the image at 31. Object at 31. Where should be the image form if the candle is placed from the towards the lens at a position of 31? So let's discuss then where she is putting. Let's check where she is putting. So this is the lens here, and this is at 50. This is at 50. This is 50. The lens is placed at 50. And now the object is placed from here. This is 0 and this is 50. Okay. So now she's putting the object at 31. So she's putting the distance as 31 from here. Okay, this is 31. Don't think that it is everything that is being given here is calculated from this 0. Okay, not from the lens. So you have to solve the numerical problems by calculating the value from the lens by calculations. Okay. So here, what you need to do here is this is 31. So what should be this distance? Tell me. It should be 19.
Yes, sir. 19. Focal length is 19.
Now the object is placed at focus.
Yes, sir.
And when the object is placed at focus, where should the image form? In case of convex lens, sorry. And the object is placed at infinity. Object placed at focus. It should be image will be formed at infinity. Okay. Let me explain you how it is formed. Let me give you. Like this is the object here. Sorry, convex lens. And if you are just putting this one, this is the focus. This is the radius of curvature. This is the radius of curvature. And if I'm just putting this object here, okay, and this is F2, and then this is R2, F1, R1. So if you are putting this object, first ray will pass through this one. And if it is parallel, it will pass through the focus. And next ray will pass through the optical center, this O, from the top of this object. And they are not going to meet anywhere. They are not going to. If you draw with this scale, these two lines are almost parallel. So we can say that they will meet at infinity. At infinity. Okay. So the image will be formed at infinity. Got it? So if it is placed at 19, 19 means at focus, the image will be formed at. When the object is placed at focus, the image is formed at. When the object is placed at focus, the image is formed at infinity. So question number 3. What will be the nature of the image formed if she further shift the candle towards the lens? What should be the image will form? Tell me. Yes, what will still be. Now, if she further shift the lens, means if she is putting the object between optical center and focus, tell me.
Then it will become virtual.
Yes, virtual image will be formed. Okay. And if I ask you that where should be virtual image formed in the lens? Here or here? At A position or B position?
B position.
In the B position. Yes, B position. So let's draw this case again. Okay, let's draw this case. This one. F1. This is F2. This is R2. Okay, I'm just putting this one. Okay, since the enlarged image, just student, you need to keep in mind that whenever you are forming the image, means image diagram, and you know that the result of the image is magnified, then you need to take the object a little bit smaller in size. Because if you take the object of bigger in size, then the image will be formed like this, of bigger in size. Okay, this one. So this is not, means you will not be able to make the proper image formations. So you know that convex lens always formed a virtual magnified image. Whenever a convex lens is going to form the image, it is always virtual and magnified. So when it is magnified, you must take the object of an appropriate size, not so much large in size, not so much smaller. Don't take like this. It should be of small in size. Okay, like this. If it is, you know that if the diminished image is formed, it always form diminished image. But when, it form real diminished image. So whenever it is forming the real diminished image, and where it is formed, when the object is placed beyond R. So when you know the result is diminished image, then you take the object as a small bigger size, so that the image will form. If you take the size of this one like this, then the image will form like this. So this will not give you an effect. So when you know, then the image is formed as diminished, take the little bit a bigger size of the object. And when you do, then the image is forming, that is magnified image, then take the size of the object as small. Okay. So just taking this one, the size of the object. Okay, now we will pass the first ray parallel to this one at the top. Don't pass this ray like this. Don't pass this ray like this. Always pass the parallel ray to the top of the object. Okay, like this. Okay. Okay, when it is passing through the parallel line, it will passing through the focus. So it will pass through the focus like this way. Okay, and the second ray will pass through the optical center. So second ray, I'm just passing through the optical center. When you're drawing with the scale, okay, so it because I'm not having a scale here, so I'm just drawing it like this way. But when you are having the scale, so you will see that they are just having a distance that is neither parallel, they are just increasing the distance. So you'll find that they are not going to meet anywhere. So we just think that they are going to meet somewhere behind the lens or at the same side as the object is. They are going to meet here. Now this time the virtual image, this is the virtual image is formed. And don't think this is a particular position that is it will form between RF. No, it can form here also. It can form here also. It can form here also. It does not have any specific position that virtual image is always formed between R and F. No, it is not necessary. It can form at R also. That we have done the previous question. Okay, that we get the 40 as a value when the focal length was 20. So it can form at here also. The virtual image can form anywhere. It does not have any particular value to form between R and here and no. Got it? Got it, everybody in the class?
Yes, sir.
Yes, sir.
Okay, I'm moving to the next point here. Now draw the ray diagram to show the formation of image in in the case above said. So we have done this one also. Okay, so these are very simple questions. Okay, but you need to keep what you need to do here is that dear students, you need to keep in mind that you need to use proper sign convention for solving this numerical, and moreover you need to have the basic knowledge of the image formation, that if the object is placed here, okay, you must know the answer before solving the question. You must know the answer that what should be your approximate value, because you know the object is placed between R and F, and it is given 20. Let's suppose the object distance is given 20 and object is